we'll introduce the different components here in the HPLC. All right, so again, up here we have our what?
Water.
Solvents.
Our solvents. All right. Why are there multiple bottles?
Because you have different percentages depending on your extract or your HPLC method.
Okay. I mean, my method might say I want 10% acetonitrile, but I can make a solution that was 10% acetonitrile, right? So what is the advantage of having 2 bottles?
So that
That way you don't have to make solutions over and over again.
All right. But the real reason is because you can do a gradient, where you can alter the dilution concentration over time, right? Because the pumps can control that, right? There's a pump, there's 2 pumps and a mixer where you can slowly change the concentration in the form of gradient dilution. It doesn't look like anybody had to do that, but that's why we have multiple solvents up here. It also can facilitate our lives if we're trying different ratios and we don't want to remake a solution every time. So our solvents up here, we have 4 different solvents, A1, B1, A2, B2. The 4 different tubes come down into the mixer here, or sorry, the degasser. The degasser removes bubbles, but it doesn't remove big visible bubbles. It just removes the microscopic small ones, which are very problematic for columns. And so in the past, you would have to degas all of your solvents before you used it in any LC method or any LC instrumentation. So this degasser is very valuable nowadays, right? So the degasser removes very small bubbles, and then the solvents come into this area here where they're being pulled by the 2 pumps. Okay? So we want to verify whatever solvents we're going to be using that there's no bubbles in those lines. Here we have some bubbles in this line, in line B2, but this is back here the 5% ethanol solution that we're not going to be using. Click on this to see it going. Okay. So these are our 2 pumps again. Right here, these are the 4 spots where we can open up the tubing and allow air bubbles to come out, to purge the lines if necessary. All right? When you do that, you want to make sure you don't let water fall onto this thing right here. Do you guys remember what this little bit does?
is the sensor.
It's a sensor for leak,
Spillage.
right? So if there's some sort of leak, it wants to shut it down for you so you don't waste your time, because if there's a leak, it's not doing what it's not doing what you think it's doing. And there's many spots where it will detect a leak in different components here. This little valve here, do you guys remember what this is?
It directs it
Yeah,
into
directs it. You can either go right to the waste if it's lefty-loosey, right? And then it'll never go to the column, it'll just go right to the waste. All right? And that's generally how you would start things up, because you don't know if there's bubbles in these lines and you want to make sure there's not. Okay? Right, being it tight again will make the flow go over the column. All right, this is our auto sampler area, and this down here is, what is this? I don't know what this is. I don't know. I think it's just a nice stain. No, I don't know. It says therm, but I don't think it's really temperature of any sort. These 2 components down here are the detectors. This one is our visible and UV detector. Here's our visible bulb, and here's our UV. Oh, sorry, these are the bulbs right here. Visible bulb, or UV bulb, and the visible bulb. And these are expensive. We do have replacements up here. I think we still have them. Here's the UV bulb. So if they burn out, you can change them out, but you usually want to keep them off when you're not working on this. Okay? We'll turn them on now, though, because we're going to start with the instrumentation. There's also a fluorescence component in here for a fluorescent bulb, in which you can monitor the fluorescence of your material if you want to do that as well. Okay? And that is after it goes through the column, right? This is the column here. These 2 little pieces right here are heating elements that will increase the temperature, and you can control the temperature of the column here. This part right there, do you remember what this little thing is?
And that's the
Protects it.
Yeah, it protects it. It's called a guard column. It has the component, the same material as the column does, so that if something's going to be either polymerized or clog or cause problems to the column, it'll cause it here first. The other columns that we have in the, and we have quite a few different columns, but here's an example of a different column. This is a size exclusion column, and we have another guard column on here, because the guard column should be specific for the column. Does that make sense? Because it wants to have the material that if you do change columns, you always want to plug the columns, right? Make sure that evaporation doesn't allow a lot of air bubbles to collect inside the column. Okay, so everything now should be on. And I'll try to start up the software here. Instrument on line 1. There's our software shortcut. And when the software first starts up, sometimes it doesn't make electrical contact or can't communicate with the components here. And so it starts listing the components that it can't communicate with. That's all right. Sometimes the software will open and they won't be communicated. So it had no problem finding everything that time, so everything came up green. All right, we also are flowing right now 1 mil per minute. I'll loosen this up though, just to make sure that there's no bubbles that we're not aware of. All right, so right here you can see the pressure, and there's a pressure limit set. You can click on this region right here, left click on it, and bring up a menu. If we click on setup pump, we can set our maximum pressure. The maximum pressure that it's set is 150 bars. All right, so we can alter that, but we don't want to change that. We can also control the flow here. I'll put that up to 3 mils a minute for a second here, as we're just diverting. You wouldn't want to do 3 mils per minute over the column. It's a little bit too high a pressure. But because we have the divert valve open, we're just clearing out the pumps, making sure there's no air in this region up in this area, right? And you always want to make sure we have plenty of solvent. Not a lot of solvent, but we do have some there. That's the acetonitrile. That is A2, and the water is B1. So yeah, A2 and B1. All right. The way that, when that A2 gets too low, which is pretty low now, we probably want to add some acetonitrile to it. And after we're done adding acetonitrile to it, you have to click here and again left click on the bottles and then go into solvent bottles filling, and you'll have to tell it how much you actually added. And we always put in about 100 milliliters less, so that there's some wiggle room just in case things aren't. It's supposed to shut off when there's only 0.2 liters left, and the pump is not supposed to be running to protect it, but just to make sure, we always give us a couple 100 microliters to be safe. All right, so we can control the flow rate here. I'll bring the flow rate back down to 1 mil per minute. All right, so now we're at 1 mil per minute. Does anybody know if are you getting ready to use this? Mm-hmm. But you had methanol and acetonitrile, so it won't help to flow it at something special for you right now because you don't have methanol. We have 10% methanol there, but yours, you don't remember your percentages, do you, by chance? Okay. So we'll just turn this off for now because it doesn't help to have it flow. Yep. So we can click on this area again and left click on setup pump, and this region right here is where we can adjust our method, the main part of our method. The main part of our method is how much solvent or how much time is going to pass, the flow rate. Right now we're at 95% B, which was water, right? So we're saying from 0 to 15 minutes, stay at 95% B. That means 5% acetonitrile, flow rate of 1, and then the stop time is 15 minutes. So at 15 minutes it would be done, and then it would go on to the next run, depending on what we have set up here in our table. All right, so you have flow here. Now, the flow, if I started at 0, so if I were to say OK here, and I just push start, right? I started it, and it's at 0. It will start, and all the instruments, the components will start doing stuff. and they'll talk to each other for a while. The auto sampler will start taking your sample and put it in, and then the flow will kick in. The flow will kick in according to this, whatever your elution, whatever your method says, right? The flow will kick in. And what's good about starting it with 0 mils per minute being shown there is when the flow kicks in, then you have, at the end of this, the method, it's going to go back to 0, right? It'll always go back to whatever you started it with. So if I have it on, for example, if I turn it on to have 1 mil per minute, and then I push start, and the whole thing starts, after it's done, it's going to go back to what? To 1 mil per minute. Does that make sense? And then you have to be here to shut it off to make sure you don't just waste a bunch of solvent down the drain.
So you put it as, you started at 0, but where do you?
So this little thing right here is just kind of like the instantaneous flow, what the flow is right now. So if I put it at 0, and then I can push start, and then when I push start, as soon as it's all ready to go, it loads the sample, and as soon as it's ready to go, it's going to follow the parameters here, which is for 15 minutes, 95% B, 1 mil per minute. All right? What do you think the best first thing to run would be for you guys? First, I mean, probably better to run the standard first, right? Maybe a high concentration of the standard. You guys got a range yet? Have you guys talked about or thought about a range of your standards?
Mine's 0.1 parts per million to 10.
Okay, so 10 parts per million is your high. So if you run that first, it'll be good to run it first, because then you'll be able to see when, because all it has is caffeine, right? Nothing else. So you'll be able to see where the major peak is, and that elution time will tell you how long each run has to be, right?
Okay.
So if the elution comes off at about 7 minutes or something like that, then theoretically you could have only a 10-minute run here. Does that make sense?
Mm-hmm.
Now you do want everything else to come off, because if there is another main component in there, it won't just have caffeine, right? It'll have other stuff in there, because you not just purified the caffeine. You've got the caffeine, but you also have other organic components in there, right? Because there's nothing in your digestion and extraction that would have prevented other organic chemicals from getting in there, right? So you're going to have probably 3 or 4 peaks, maybe even 10, and then a larger one hopefully will correspond. Maybe not the largest one, but a larger one will correspond to caffeine, right? So if you run the standard first, it'll give you an idea about where you should be looking for the caffeine, and then you can run a sample and see how long it takes for everything to come off the column. Because if it takes 15 minutes for everything to come off the column, then you need to kind of wait all that 15 minutes, because you want the column to be clean before you run your second sample. Does that make sense? Theoretically, if the caffeine's the highest peak, then you could do every 10 minutes. But then you would get this overlap that you would kind of go adding on to as time went by. And then there could be a chance that the overlap would correspond with the caffeine peak and augment it or shift it, or not augment it, not shift it, but augment it or give it a shoulder or something.
So we should do a standard and then a sample and then put all the other ones in.
Well, that's just to kind of see what's going on, right? Do a standard, see what time you're looking for. Do a sample and see how long that takes to run the whole thing, and then you can, start over with all your standards, get yourself a curve while you're waiting, or if you're going to come back and analyze all the data later, it really doesn't matter the order, right? Okay, so if you wanted to change, and you would say, okay, percent B is going to be 0% B. That's going to be all percent A. Right? And then you can just say OK, and you can say File, under Method, sorry, Method, Save Method as, you want to save the method and you can name it something specific to whatever you're doing. Does that make sense? So now you know that A1 is where you want to put your bottle, and if you choose that method, it will do it like that. Whereas somebody else can change the method in here. And then say this method differently, right? So this is 90% B, which is the water, and 10% A2. And A2 is our acetonitrile, is that right? Yeah. Okay? And so then again, you'd want to go into this method here, save method as, and give your method a special name. All right? Other than that, wait, yeah. You guys aren't done with your extractions yet. You're done with your extractions. So yours is really the one. Have you done it? You haven't done anything yet, right?
Mm-hmm.
And you haven't done anything yet. So yours is the one that'll probably end up going first. So as soon as you want to get that solvent ready, we can get it up there and start equilibrating the column. That would probably be the best thing to do to make sure that by the time you're done, or are you done? You're done? You ready to go?
No, I haven't made my standards yet.
Okay, well then you can, either way, if you take a break now and get the solvent ready, start running that now, so when you're done with your standards, they're ready to use.
Right now?
Does that make sense? Yeah, I think you should stop and do your solvents first. Does that make sense? Or what? Because if you have your solvent ready, then it'll take about 15 minutes to run, and then to equilibrate the column and everything, make sure there's no peaks. And then when you're done, you can bring all your samples over here and line them up, run a couple to see how long it's going to take, and then start underneath. Okay? That'll save you about 20 minutes if you do that first, at least before you start. All right, I mean, all of these have, oh wait, we didn't talk about this. We should talk about that again. If I click on this area, this little thing right here represents the column. If I click here, instead of column thermostat, I can change the temperature. I don't know if anybody got any information about the temperature of your column. You can change that, and that'll change in the method as well. Here, set up DAD signal. Whatever signal you're interested in, you type it in here, and that will be called method specific as well. It's nice to check a couple, just in case you think that one of them isn't working for some reason. This area here, the auto sampler, the sequence table. In here, you need to tell what vial it's going to be taking. You need to say what method. So we were working with the ACHEM method. So how many injections per vial? That should always be 1. Sample type, whether it's a sample or calibration, we just always put sample there. Even if it's a calibration, you don't have to change that, just leave it a sample. And then injection volume, what did we say the range was? 0 to 100 microliters. So 10 microliters is a good place to start, but that's something that you might want to change as well, right? If you run your sample at 10 microliters and you see that all the peaks are off the chart, right? You want to decrease your sample size so that all the peaks, and you'll know where the standard or the caffeine peak is. So you want to make sure the caffeine peak's in the right range. And the first sample that you should run, which one do you think you should run first to find out the right range? So we talked about running the standard first, right? A high standard first to make sure that the caffeine peak is in the right frame, both on the x-axis and the y-axis, and then run a sample to make sure that again, y and x-axis are have the right parameters.
Or the biggest one?
Yeah, the biggest one, right? So that if the peak is really high, your y-axis will be okay. Does that make sense? So then that's just a kind of like a test run. Now, again, you should be able to put about 500 microliters of sample. I don't think that'll be a problem for everybody. Put 500 microliters of sample in each vial, right? If you start off with a 10 microliter shot, and if the pumps are too low, go up to 100 microliters or whatever. We want to have the flexibility to run a couple times. All right. So the injection volume is something you have to put in there. Sample type, injection volume, and you can append a line. You can copy and paste the method name. Let's see, the data file. Why wasn't there anything here for data file? You need to make sure you have a different name for each data file. If you don't have a different name for each data, a sample name too. If you don't have a different name for the data file and the sample name, then they'll overwrite each other. Does that make sense? Now, if all of this is going to be saved in one big folder amongst everybody, you'll have to make sure that your samples don't have the same names as anybody else's. Does that make sense? And so maybe use something like your initials in the sample name and the data file name, but they, again, can't be the same as each other. All right. Let's go back and try that again. Sample table, let's make this file 2, so you can see how the files that are going to be run by them. Under sequence parameters, you need to make sure this file name is the date, right? So today is 22nd. So 5/22/13, and then something that has to do with the what's that? 7. Oh, that's right, 7. May 8th.
How did you get to this window?
How do we get to this one? When you say OK, they're going to say that folder isn't made yet. You want to create it, and you always say OK. To get there, you click on here, and you go to sequence parameters.
Okay.
Okay.
So it'll just save it into that folder?
It'll save it into that folder. All right. Now, once you've collected all your data, right? You've collected all your data, and you want to go analyze it. Okay. So this is how you analyze your data. Into the view, you go into data analysis here. All right. And in data analysis, you can open. You click right here. You can open some files. And under data, your information will be somewhere under data here. Okay. The date will help you find it, right? So here's, so this is, that wouldn't be the right month. Oh wait, that would have been fall. Let's see if we can find last year's. Okay. Oh. Let's move that one. All right. So here's an example of a run. Oops. Okay. So when you open, there's a couple ways to do this. When you open the file, your data file, you're going to get this underneath, and then it also opens up this report here. Okay. And if I just want to look at this report, then I can scroll down through here. This is the run right here. Right? I can see the time here. Ran for about 11 minutes. Versus absorption here. I get the signal information. It was at 254 nanometers. This was being monitored. I'm pretty sure that this is caffeine. I'm not positive, but it looks like it came out at about 9 minutes there, right? If that's the peak. But it's very, very small concentration, maybe a low standard or very, very dilute solution or small volume size. But the information here identifies the peaks. I don't know why it didn't integrate them. But usually you'll get this sort of a chart right here, your data report, that says retention time. So it tries to identify the peaks, and it identified one at 2.5. 10.3. Alright, so this looks like one about 10.3, 2.5. I don't know what was 2.5. Oh, well, no. Oh, this is aspirin. Okay, but in this chart right here, you'll often have all the information you need in terms of the area. The area under the curve will be integrated for you. If for some reason you didn't do it, you can not use that report, and you can, every time you reopen it, it'll reopen that report. So if you want that report, you can get it. And I'm not sure if this can print over there to the computer or not, but you don't need to print the whole report. You can just copy down that table, right? The retention time and the peak area. Or if you just want to close the report and do it manually, that's okay too. So if the peak is significant, so in this one here, the peak isn't identified as significant because the background noise is almost as big as the peak, right? So they didn't identify it. But you can identify it by finding out where the retention time is, right? So the retention time looks about 9.725, right? So that's, this doesn't need to be, that's within 3 significant digits is plenty of accuracy. And then you can identify the area under the curve by clicking on this integration bar here and integrating like this. Okay, so here's a run. If we look at the report on this run, you can see that all the peaks are given retention time, and so then you can see the retention time.
What's up with the giant slanted line under the hours for?
This one here?
Yeah.
Well, because this signal went down, it identified that as the baseline.
Oh.
So if you see something like that, then
And the peaks are probably off.
the area is going to be off here, right? But again, this is an example where, so hopefully your data will come out nice and clean, and you'll get a retention time and area, and those are the only values you really need, right? But again, and this is another example of something that could go wrong. So if you have something like this, then you can just find the area by fixing it like that, right? So you can identify any area you want to, and you'll want your specific data. Does that make sense?
Yeah.
Okay. I think we've described everything here. We can go back to our method and run control like that. Otherwise, after you have the run in there, the method that you want, and again on the sequence table, you want to make sure you're using that method, because if you're not, it's just going to use some other method. The injector, one thing that you can change on the injector, you can change there's a lot of things, but for you, all you need to change is the injection volume. But it should correspond to whatever you had in this table. Okay?
So once you go into this,
Sequence table.
yeah, how do you save it again?
This you just say okay. And
Okay.
it'll save it.
I think you only use the.
Okay.
So when this runs, it's going to first do vial 1, this method, 1 injection, 10 microliters, right? Save the data as data file 1, sample name is 1. After that's done, it's going to run vial 2, this method, and so forth. So let's say a couple of people have this going on, and you want to put your own stuff in, right? If you want to put your own stuff in, and so if this is running right now and you don't want to wait around to start your own, you can just come in here, append a line, put in whatever your new vial is, your sample name, your method name, which could be something slightly different because you made some changes, injections per volume, so it's still a sample, and you want to give this sample name and the data file something that corresponds to it.
And then where's the file that we put it into?
And then the file that this ends
Oh,
up
sequence
being in
parameters,
is
okay.
under sequence parameters. This is going to be the same, though, right? This is going to be the same because if it's in the middle of running, you just come in and change this, then it's saving all that data into this sequence, this file.
Okay.
All right. So if it's running, you still have the opportunity, a chance to come in and add some more files underneath. With the new method, it will run the parameters that you want it to run. Okay? Now, one thing that you have to be aware of is if you are running a different solvents than the previous person, right? So if Chloe starts with her 30% acetonitrile, 70% or 25, 35%, whatever it is, acetonitrile methanol, right? But you guys are going to be doing acetonitrile and water, right? Then what you need to do is you need to, again, you're going to come in and make the appropriate changes in your method. Say your method has a different name. And
You have to climatize or
yeah, you need to equilibrate the system before you actually run it. So one way to do that, equilibration, if you don't want to be around, right, is to just run one sample, kind of like a sacrificial sample, right? Just run one sample and have it put some sample on there. The whole thing will run, and then you run the same one again. The second time it runs, then it will have been equilibrated from the first one. Does that make sense?
So, put anything,
Or yeah, you can put anything. Or another,
just create a fake method.
create a big method that runs for 30 minutes or however long you want to equilibrate it for, and maybe only puts 1 microliter of one of the vials that you have water. Does that make sense? Okay. Hopefully we can figure everything out from this. All right, good. Is it still recording?
Yeah.
All right.